Is it visible?
Yes, ma'am.
Yes, ma'am.
Okay. So today we are going to discuss little bit of what you have discussed in the last classes and some new topics. Then gradually I'll be covering the basic ideas of classes and objects, then constructor, destructor, okay, etc. So today we'll be checking out some of the things that you have already done, some of the concepts. Okay, just to recall all of them, and then some new topics. Okay, so the books are same books we are following. I am also following the same book. So all of you know that we have shifted from procedure oriented programming to the object oriented programming due to some reasons. That is, the reason is that the procedure oriented programming is mostly they are giving the importance to the functions, not to the data. So their main focus is on the functions, and they are not able to discuss the binding between the function and the corresponding data in a well-defined manner. So we can recall the result processing system to create rank list or finding the attendance defaulters that sir has already discussed. So in that we have seen some of the some of the functions were there. Okay, so what we do normally in procedure oriented programming, we divide any problem into several parts, and each part we represent by some functions, and then our aim is to solve the functions, and then each of the function will be contributed a part of portion was part of the solution. Okay, and as a whole we will be assembling all the solution and getting back the response, that is that final result. Okay, so normally if we see it can be shown as a flow chart, all the functions. Okay, so I have taken the same example that the main program can be divided into read marks, then we can create the rank from after reading the marks, then we can sort them, but from that we can create a rank list. Okay, and for the attendance also there is a table, 2D array was there to read the attendance, and then we can find the defaulter. Okay, and the display rank can display based on this rank and the defaulter list. So we can see in this manner also that one flowchart is used to organize all the functions that a program is having. Okay, now the problem of having procedure oriented programming, that we all know that if there is a multi-function program, so many important items are need to be placed as global, as well as many items need to be placed as local. For the local data, that will not create much problem, but if the data is global, then there may happen that some changes may occur in the data. One function can change the data which some other function may be using that time. Okay, so if it is a large program, it is very difficult to identify that which data is used by which function. We are not sure that this function, this data is local to this function. That means data and functions, they are not tightly coupled in procedure oriented programming. So I think sir has discussed cohesive and coupling. Okay, so with that difficulty, we are now trying to find that if there is some way to solve this problem. So that is why we should learn the object oriented programming, and it is also a fact that we cannot model real world problems in procedure oriented programming, whereas our objective in object oriented programming is to model the real world problems. Okay, how we will be modeling? Like we'll be writing down different, say for example, sir has used this example previously also. For example, we can declare some variable like int a or float b, etc. So these are all built-in variables, or means already it is known to the compiler. This type of the data type is already known to the compiler. Okay, but if we want to create some variable that is of our type, that is of user defined type, say for example complex. or if we want to create a variable called stack. So for that, what can we do? So previously we know that if you want to create some kind of variable that is or maybe say some student, we want to create one variable called student, okay, and the type is student, and then we can create this is the data type, and we can create different student called S1, S2, S3, etc. Okay, say for example, if a student is having we want that student will be having some kind of characteristics like the student roll number, ID, and that is roll number or ID, then name, age, address, city, etc. Okay, so these are the characteristics, and there may be something that student will be doing, that is the action for the student is giving exam or attending class, or maybe attending some say extracurricular activity, etc. Okay, so there may be some characteristics for the student and some action for the student, that is student may have some characters, some behaviors, etc. Okay, so that how we will be representing in procedure oriented programming. So one of the example of procedure oriented programming is a very famous language, that is C, that we usually implement all these things in C. Okay, so now if we want to implement all these things for student, if you want to implement its behavior, or if implements its characteristics, for implementing characteristics we will be defining different variables, different types of variable for the student, like for the roll number we will be defining some integer, for age also, for date of birth also. Okay, and for the behaviors, how we will be implementing the behavior? By using some functions. So we'll be writing down some functions, some codes to represent the behavior of the student. So it is always not possible in C that we will be binding them together so that they represent a student. Okay, so I think all of you know these things. We can create structures to have different types of variable in it. But can we have in a pure C language? Can we have the variables as well as the functions within a structure? Is it possible? I think it is no. Okay, so enough discussion has been done on this. So based on this discussion, so this is the problem. Okay, one of such problem is in the procedure oriented programming. So to solve this, we have means introduced one approach that is known as object oriented programming. So in object oriented programming, you have sir has discussed several features of object oriented programming, several differences between C and C++. Okay, so all the things have been already discussed. I'm just taking a little bit of time to just recall all this. Okay, once again. So for object oriented programming, in simple words, previously we are defining the problem, we are dividing the problem into some functions. Now we will be dividing the problem into some objects. Okay, so objects are some real world entities. Okay, like the student. Okay, so we can have student A, we can have student B, we can have student C. So in this class maybe we are having 200 students. Every student is having some characteristics that is represented as the data for the student, and some actions that is represented by the functions. So let us take we have 3 students. Okay, one is student A, one is student B, and another is student C. Okay, 3 students. So what we have inside an object, in an object we normally bind the data and the function which operates on this data together. Okay, so we together bind the data and the functions that operate on the data. So these are the set of functions that can only access this data. Okay, so this is one object. Similarly, for object B also, these are the functions that are defined inside object B, which can have this data, which can access this data. Okay, similarly for these functions, this can access this data for object C. Now if you consider these lines are not there. Okay, say we have divided our program, the problem, into some objects. So we are having some objects that are having two parts. Every object is having two parts. One is data and another is function. One is data, another is function. Okay. So now the coupling part is fine. Okay. So this particular function can only change this data. This particular function can only change. This can only change. So the problem with the global data is not there. That no function can access others' data. But for solving any problem, we need to communicate the answers. We need to communicate answers or the results for each function. Otherwise, how can we solve the problem? So for that, we need to have some kind of communication among the objects. So how will we doing the communication? We'll be doing the communication via the function. The function can call the functions. Okay. So how we are doing? So these lines are required because the objects communicate with each other through their functions. Okay. So how, if say now I want to access the data, this object C want to access the data for object A. Okay. Say I want to access this object C want to access the data for object A. So what it will do? It will first call its function. Then from this function, it will call the function for object A, and the object A can access this data. So indirectly we can access, but not directly. So there we are imposing some kind of restrictions. So what we are doing when we are binding this data and functions that operate on data, when we binding them together, what we are doing? We are hiding the data from outside world, but also we are giving a little bit of way out so that this particular data and function, whatever be their result, we can communicate that to the outer world. Okay, so this is the idea of objects and the communication between the objects. Okay, is it okay? Clear?
Yes, ma'am. Yes, ma'am.
Okay. Okay, so we all know that in object-oriented programming, these are the features. Okay, so I'm not going to discuss all this. It follows a bottom-up approach, and normally we divide the program into objects, bind data and the functions together. Okay. Okay. Now what is an object? Okay, just a second. Didi, একটু ওইদিকে গিয়ে কথা বলুন. Okay, so now the thing is, what is an object? So we all know that objects is a basic runtime entity. It can be anything in real world. You can represent a smartphone, you can represent a phone, or you can represent a vehicle as an object, you can represent a building as an object, or you can represent a student like person or teacher or anyone as an object. Or okay, so we all know this thing. So how we will be representing? Every time we consider object, we'll be considering that object is having data, that is its characteristics, and functions, that is behavior or action. So these two things we'll consider for an object. Okay, so now consider that if I tell you that taking the same example, that if I tell you there is a car and there is a cycle, there is a scooty, and there is a motorcycle, and there is a jeep. So what are they? All of them: car, cycle, scooty, motorcycle, and jeep. What are they?
Objects.
All are vehicles.
Yes,
all are type of vehicles. Now this car and jeep, they are having 4 wheels, and these cycle, scooty, and motorcycle, they are having 2 wheels. Again, car and jeep, they are having some engines. Scooty and motorcycle also having engines, but cycle don't have any engine. Okay, So how they are different? All are objects of a class called vehicle. Okay, so we can say this, all are objects, all are similar type of objects. They can be known as a within a single class, same class. Okay, so we can say that they are all objects of same class. Okay, say for example, if I create this thing, int a, b, c. So what are they?
Variables.
Which type of variable? Integer variable. So can we say a, b, c, they are variables of type int? We can say this one. So now if I say this car, then scooty, then dot dot dot, all of them, they are variables of, sorry, my pen is creating some problem, type vehicle. Can we say that?
Yes, ma'am.
So these are our objects or variables of type vehicle. Okay, so each object, we can say they are associated with a data type of class, any class. Okay, or we can say whenever we create class, we create similar type of objects. So by class, what we are providing? We are providing by class, we are providing a template or a format. Okay, that every object of that class should follow. Okay, that means we are creating a format of vehicle by some characteristics and some actions. Okay, like the vehicle will be having some wheel, the vehicle will be having some engine, it must have some color. Okay, maybe you can specify the speed per hour, etc. Okay, so if I specify all these things, and the action is that it can move forward, it can move right, it can move left, okay, or it can have some maybe you can speed up the thing. Okay, so different types of action it can take. So depending on that, we are creating the format. Format means say I told you every person of this class, some days 1 or 2 days before, I have created some class called in the Moodle. Okay, so I told you that this is an action, there is a key I am providing you. You go there in Moodle with your email ID and then you join in this class. Okay, say the same thing if I want to do offline. Okay, if I tell you that I'm creating one form, and here I have written the name, provided one box, then roll number, one box, then branch, one box, etc. Okay, and then I told you I distribute this thing to every student in the class. I'm doing in the offline mode. Okay, then I told you every one of you please fill up the form and give it back to me. So what we are giving you, what I am giving you, I'm giving you one format, isn't it? I'm giving you one format for a form, maybe some registration form or something like that. Okay, and I told you to do this, give some data here, and also do some action like pasting your photograph. Okay, you're pasting your photograph. So I told you to do these things. So the format means we are defining the thing, we are defining the class. This is a format for a form, any registration form. So if I think that registration form is a class, every person is given one form, and when you come back, when you give it back to me, it is a filled up form with different photographs and different data in it. So the same thing, same concept is used in classes and objects. If I consider this thing, let me erase. say let me consider this the thing that is mango, apple, orange, etc. Okay, say I told you there is a class called fruit. Okay, now there is mango, apple, orange. Okay, and there is a class called fruit. So what we are providing for a fruit class, we are providing one format, and I told that you should fill up this format. Okay, so what is the format? First is number of seeds, then color. Okay, maybe the shape, etc. So these are the characteristics of a fruit. Okay, so if I tell you this is the format for fruit, and then I told you to fill up this format for all of them. So for mango, the number of seeds is 1. Then color, maybe green, and shape it's elliptical. Okay, then for this apple, the number of seeds, say 8 or 10, color red, shape is round. For orange is number of seeds, say 9, 10 or more than that, color is orange, and shape is again round. So how they differ? How they differ? The mango, apple and orange, all are fruit, but how they differ? When you put the values to them, they differ, isn't it? All of them are having this format. They possesses this format. All of them are having number of seeds, color, shape, etc. But how they differ? When you put these values, then they differ, isn't it?
Yes, ma'am. Yes, ma'am.
So my point is, when we create some class, actually we are defining a format that every object of that class should follow. Okay, so when we provide data to that object, when we create data for that object, okay, that time we can differentiate between the objects. Okay, this is the idea. So for this object-oriented programming, there are some features that you know. These are the basic features, that is encapsulation, inheritance, and polymorphism. Okay, so for encapsulation, we can say, or data abstraction. Do you know what is abstraction? What do you mean by abstraction? Sarah's discussed it.
Yes, ma'am. Hiding details.
Hiding details and giving a little bit of idea, little bit of details. Like he has discussed one idea, like if when you are giving your exam, you are giving 5 papers or 6 papers, you are writing your exam. Okay, and after submission of your copy, you don't know what is going behind that, how the copies are collected, when the evaluator evaluates is, how the marks are tabulation of marks are done, how the results are done, how the results are generated. Okay, so all this grading system and all this system, you don't know about it. You just submitted the answer copy and then you wait for the result day and the result is published. So you don't know inner physical activities, all these activities. Okay, so we can say these are the upper level activities that you know, that is we are providing you copies, then question papers, then you are writing the question papers, you are writing back and giving back to us. But after that what happens, you don't know. Similarly, for example, say if I want to buy a new car, normal person what they do, they go to the showroom and then maybe I'm having some preference that I'll be liking some red car, so I'll be asking them what are the different shades in red that you're having this car. Okay, and then maybe I am asking them for this is my budget, so within that budget I want this much of speed. If the car is having, I want some music system, I want some good power wheels, some brakes, etc. Okay, good brakes, etc. Then the salesperson, they discuss me all these things. They'll be showing me some models, and then they'll be discussing me that this is the mileage of this car. Okay, and this is having some power steering. This is having some AC, convertible AC. Okay, then they'll be telling me that the braking system is very good. It is having this ABS system and all these things. Okay, so as a person, what we are interested in, we are interested in only a part of data that we see. Okay, but we are not normally asking that how your engine is working, how the car is moving forward. When you push the brake, what is anti-braking system, what is the physical architecture, you tell me the circuitry of the electrical circuits and the other machinery parts of your, that is not our discussion, part of discussion. So we only consider only the data that we are interested in. Okay, and hiding the all other data. So this thing is known as abstraction. That is, uh, means it representing the essential features without including the background details or explanations. Okay, so you know what is our abstraction. So this abstraction part and this thing, we normally abstract the view of the data via different via wrapping up the data and functions into single unit. Okay, so we know these are the terms called encapsulations, data hiding, etc. Okay, so these are very important, and we implement all these things, all these essential properties, this encapsulation or data abstraction or hiding through the idea of objects and classes. Okay, similarly we know this the property of inheritance. That is, the son of a family, they inherit some of the properties of their father and mother. Okay, maybe say they also inherit some properties of the grandparents. Okay, so the biological inheritance, and the same thing if we want to replicate that the real world thing that we want to replicate within our programming. Okay, the same thing is known as inheritance. Like it is the process of reusability. In this process, one class acquires the properties of another class. So sir has used a beautiful example of vehicle. That is, there are two types of relationship, that is has a relationship and is a relationship. So implementation of inheritance is done by the is a relationship. Okay, so we'll be discussing this thing in the chapter of inheritance. Once again, we'll be taking this is a relationship and the has a relationship. Okay, so here I have included a very small example, like the flying and non-flying birds, all of them having the properties of bird. But flying bird, they can fly, and non-flying they cannot fly, but they have wings and all these things. And again, the flying birds can be categorized into different robin and swallow, similar to the vehicle. That vehicles can be four-wheeler, vehicles can be two-wheeler, etc. Okay, but they're having their own properties. So we will be implementing inheritance also in our object-oriented programming concept. We'll be implementing polymorphism, like different functions, they can exhibit different behavior. That is known as function overloading. And the operator overloading, like if a person is overloaded with multiple roles. Similarly, it can be done with the functions. We can have similar type of functions. Here you can see there is a function called area. We can calculate with this function, we can calculate circles area, we can calculate rectangle area. Just we need to pass different arguments for it. Okay, and the for operators also. And you know how the operator overloading is handled in C++. All these things has been discussed by sir. Okay, so now let us see how C++ works. Okay, so in the general structure of a C++ program having these four parts. Okay, first we need to include the files, then we need to declare the class. Before using the class, we need to declare it. Okay, next, the member function of the class need to be defined. That means each class is having two parts that we know. The class is providing the format, that is object, the data part, and the functions that operate on the data. So we need to declare the class by declaring the data members as well as the member functions. Okay, and the member functions need to be defined. So we can do it all together. We can do it within the class declaration also. We can define them, or out of the class. and the main program, that is our main. Okay, so main till now in C we have used these two parts, include files and main program. So these two parts are new, the class declaration and member function definition. So we need to see what are the syntax and how we will be doing. So gradually I'll coming to that. Okay, so now this is a general form of a class. So first we'll be having some include files, then the class declarations. And this is the class declarations, and within the class declaration, either we can have we'll be defining all the members. Okay, and then the member functions can be defined outside. And here we'll be creating some variables, executable statements, all of them. Okay, so from main we'll be creating the objects. And then we'll be calling all the member functions and doing all the things. Okay, so these are the general structure. Next is if I want to add two numbers. So this is very simple. I'll be asking one number, two number, then we'll be doing the adding. The same thing if we convert them into some code. So this is the code. So basic difference between C++ and C is here we can see different things. Sir has discussed it thoroughly, that what are the different things. Okay, so the basic thing that mostly we can see here, that is C out and C in. So this is also discussed, that C out and C in, and these operators. So what is C out and C in? They are
Objects.
They are predefined objects. Okay, so where they are defined? Predefined. IO stream. So what is IO stream? What is IO stream?
Library function.
Library function or library
class
template? Library. One told me template. One told me class. And header file. I am telling it header file. So who can tell me the differences between them? So what is library or what is template? First you tell me. Is it a template? And have I used any keyword called template or keyword called class here? There is no class included in here. Only one main function is there in this program. Only one main function is there. So class and template, this is not class and template. Library and header file, which one is it?
Header file.
So what is the difference between library and header file? You know, what is the difference? So, and what is this one? Do you know this one? What is this one? Using namespace std. Other things sir has discussed, like the C out, C in, then different manipulators. A very nice programs has been done by him, showing the manipulators and all. Okay. So let us discuss what is this, what this part and this part. Okay. So these are the differences. So this compiler you can use. I am using this compiler sometimes for showing you the program. This is an online compiler. This you can use. Otherwise, you can use any standard offline compilers. Okay. So this I am skipping all the standard C in and C standard output stream, input stream, etc. This has been discussed. We know the commenting portion. Do you know why comments are required? This is a good programming practice to use comments inside your program. Not only commenting out some portion, but also to let the user of your program know that what is going on. Say you are creating some for loop for initializing the matrix. Okay, so for that, you at least need to know, let the user know that this is you are creating a matrix. Okay, so for good documentation, the comments are required. Okay, so always try to produce some comments in your program. Okay, and keywords that you know that these are the known words to the compiler. They are having some predefined functions, purposes. Okay, so next is this compiler directives. So we can have different types of directives, either predefined, or we can create our own library files, or we can create our own header files. So header and library file, they are not used separately. Okay, so header file is a file where all the header names are mentioned, all the declarations are mentioned, all the functions declarations are there. It is having an extension .h. Okay, so it have the function declarations only, and the function definitions or the implementations are there in the library file. So the library file is having the function definitions. Okay, so both the header files and the library files, they combines and they provide some specific interface and the functionality that is used in the main program, main file. Okay, so they are used as a single unit. So now you understand the difference between header file and the library file. Okay, so when we use C++ compiler, we normally use iostream.h. Okay, and we can have also IO manip for manipulators, and other means header files are predefined header files are there. We can also create our own header file and we can include it using the #include directive. Okay, and next comes the identifier, C++ identifier. So what is identifier? Identifier means the names or the part of the variable name by which we identify anything. Okay, it may be anything. So normally we provide meaningful names to the variables in our program. Okay, like say we want to create a class for a date class, say. So there I'll be having some variable called day, month, year, etc. So these are all very meaningful names, English-like meaningful names we use. So how we are identifying that thing is known as the identifier. Okay, so all C++ variables must be identified with unique names. These unique names are known as identifiers. Here I have written some of the rules to create the identifiers. Okay. So the identifiers you can name for the variable, for constant, different functions also having some names. Okay, then they only have alphabetic characters, digits and underscores. Okay, but special symbols are not allowed. Okay, the name cannot start with a digit. Okay, it consists of letter followed by any sequence of letter, digits or underscore. So the valid identifiers like this may be a valid identifier, age, or this is also a valid identifier. Y then 2000 or Y2K. Okay, but this one is not valid because it's starting with a number. It cannot start with a number or it cannot have special characters. Okay, understand? So just you need to remember the simple rules. Okay, so identifiers are case sensitive and we can have different types of identifiers. So these are all valid unique identifiers. Okay, now the question is, why we have all these identifiers? We need to differentiate between two variables, two different variables, two different functions, etc. Now say for example, if in your library file, there is a function, predefined function called XYZ. Okay, and inside your main program, the C coders, I'm telling all the concepts of C. Okay, inside main, you are having one more XYZ. Okay, so which one is to use? So this one is there. This is already defined inside the library file, and this XYZ is inside the main program. Its definition is there. So now if this XYZ is called, the compiler is confused that which one is to take, because we have already included this thing. It is a predefined definition is there. Again, one local definition is there. Then which to use? Okay, so to solve these ambiguities, we create the namespaces. Okay, so the namespace by definition is a declarative region that defines the scope of the identifiers inside it that are used in the program. That means which identifiers we are using. We group the identifiers in different namespaces. Okay, so if you don't put this namespace std, If you don't put this, it will give you some error. That means it is not identifying cout or cin. Maybe you are using cout and cin in your program. Okay, they will be not identifying that name. Okay, that identifier. Okay, so namespace is required. Using namespace std is a required statement in your C++ program. Okay, so it provides all the standard library functions and classes. Okay, so let me show you one small program, then you understand this thing. Okay, so this is how we define our own namespace. Okay, namespace, then namespace name, and within this we will be having some declarations. And this is written using directive. Okay, like the include files, we are using hash include stdio.h and all these things, hash include directive. Here the namespace is used in using directive. Okay, so do you have any other class from 11?
Yes, ma'am.
Okay, yes, and I am also having one class. I'll take 5 more minutes. Okay, so this is, see here, what I have done here. Here the IO stream. So here this IO stream and this is namespace std. Okay, and I am creating two namespaces. This is the first namespace and this is the second namespace. Okay, so what I have created, namespace first space. Here I have defined one function called func and written inside first space. See, the same function name I have used here only in this namespace also, second namespace, but the body is different. Okay, now in main, if I don't put this one, if I don't put this line, and if I write this one, it don't know which one is which function need to call. It will ask for its own definition if it is there. If you differently write down this function inside main, it will ask this one. But if you want this one is to be called, then you can include this using namespace first space. Okay, so it will call this one and you see the output. Similarly, if you I have just changed the namespace as second namespace and keeping all the things same, and it is providing you inside second space. You understand this thing? Is it okay?
Yes, ma'am.
Yes, yes.
So any other query regarding this till now? I'm skipping all this and these things, declaration of variables that we know, we need to declare all the variables at the beginning of the of our class in C. But this is not mandatory in C++. This is a flexibility of C++ that we can declare our variables anywhere within the program before using it. Okay, and the same time we can have dynamic initialization. That means we can have two parts, means two parts combining. That means we can declare as well as we can initialize at the same time. Okay, so this is dynamic initialization, and the reference variable and new and delete operators has been discussed by sir. I'm not going to discuss all these things. Okay, one more thing is that I want to discuss. I'll take 5 more minutes. Okay, one more thing that I want to discuss is the operator. Okay, so this is very important. So in C, we can see the different block type structure. Like we divide the main program into different blocks, different functions. Then we can also create some blocks like this. Say we have created the main block. Just a second. Yeah, say we have created the main block, and within that main block we can create some other block. Okay, so this is called block. Actually, we normally create the block or scope using two parentheses. Okay, so now the problem is if some variable is declared in different blocks. Say in this block I have declared some variable and in this block I have declared some variable. So this particular variable becomes local to this block. This particular variable becomes local to this block. That means it is accessible within this block. Okay. Now in C, if say we have this kind of example, say this is character C which is globally declared. This is a global variable. Okay. Now this global variable must be accessible to all the functions. Okay. I mean, see, the global version of variable, it cannot be accessed from within the inner block if there exists another local variable that is having same name. Okay. So in C, see this first this program. Okay, this is written in C. So in C, first printf, this first printf, is value of C printing the value of C. So what it is going to print? It is going to print A because there is no other local variable C declared. Then the program will print this one. But once this one, another local variable C is declared, defined, then the same thing, if we are doing the value of C we want to pass, we want to see, it will not print A. It will both of it, they are printing B. So this is the problem of C. Okay. If you want to create, if you want to access the global variable from inside the C, from inside the C main function, you cannot do it if there are similar name of local variable exist. Okay. So it is sometimes required that we will be will be showing the local variables as well as the global variables. So that time what can be done? The thing can be solved with scope resolution operator. Okay, the scope resolution operator or this one. So this one is actually the scope resolution operator. 4 dots. Okay, 2 colons, consecutive 2 colons. Okay, so I have taken the same program here and just does the modification with this. You see here in C++ I have written the value of C here is A. Then value of this is a local variable. That means it is taking this local value, this one, that is B. And if I use this one scope resolution and see, it is showing the global variable that is again A. So you understand what is the difference between this thing, how to use the scope resolution operator. This scope resolution operator. This is the use for not only for global variables. We'll be seeing its several use. Why we are discussing, we'll be seeing it several use. Every time you will be writing down class and other things, we need this scope resolution operator. It defines the scope of a variable. That is, it is within which function or it is from which class. Okay, we define the scope that this one belongs to this. So this is the scope. Okay, so here we want to access the global variable. Okay, and if there is a local variable with same name, we can do this thing using this scope resolution operator. Okay, understand this thing? Okay, next is we can create. I'm talking about different structured or different blocks. Now, if we can create different blocks within main, okay, how the scope resolution works? Okay, so in C, the scope cannot be created inside local scope, but in C++ we can create nested scope. That means here one scope is there. This is one scope, and this is one scope. This is the inner block. Okay. So how the operators work here, how the scope resolution operator and normal operator works. So can you guess the output of every statement for this one? What is the output for this one?
20.
Huh?
20.
Value of n is 20. Then this one?
30.
30.
30 or 20?
30.
30.
30 because 30 is local. And then this one?
20.
Why 20?
10.
It will be
This
10.
is global. It will be 10.
It will be 10.
So this is 10. And next we're coming out of this block. So what will be the value of m here?
20.
20.
20 because of now value of 20 is activated, 20, and this one is again 10. So this is the output. Okay. So if there is a declaration, local declaration, then it will take that one. If there is, say, this line is not there, Okay, no local declaration is there. That time the control goes out of the block and it checks if there is any local declaration or not. That time it will not produce 30, it will produce 20 if this line is not there. Okay, so this is means this is just defined here. So whenever we access the local copy of the variable without this one, that means without the scope resolution operator, the compiler moves up to find the local declaration of the variable within the current scope. It scans upward to find the local declaration within its outer scope. Okay, so here, see here, what is the output? You can say, tell me what is the output for n?
20.
20.
20 for m,
30.
30.
30.
Global
10.
m is always 10, and then this is another block. So in this block there is no value for m is defined explicitly, no value. So what it will print? It will go out of this block.
20.
Out of this block means
20.
this block. No, not 20.
No.
Why 20? 30 is there.
30. Yes.
30 is there. So it will print 30. This block is inner, just out of this block means this block. And 20 is defined within this block. The second inner block, the first inner block. Out of the first inner block. This is the first inner block. This is the second inner block. So from second inner block, we'll go up. We'll see whether there is any local variable or not. And we'll check this thing and we'll print. This is 10 again. And this is 20. And this is 10 again. So this is the output. Okay. Say here, I have just made modification. I have put the value for m here. So the example is, so this value for m is 40 here. Now this previously it was 30. Previously it was 30. But now it is 40. Okay, you understand the idea?
Yes,
If local copy is there,
Yes,
then
ma'am.
use the
Yes,
local
ma'am.
copy. If the local copy is not there, you go out of the block, just the next upper block and go and find. If there is no local copy, nothing. Okay, you go gradually, you will go up the block and then you will be using the global one. And if there is if there is no global copy, but we are accessing this, then it will print some error message. Okay. Now the global copy can be incremented or decremented by using this plus plus and minus minus operator. So this is, you can do directly and you can update it. Okay, so this is 11. So you understand what is scope resolution operator and how it is used? So we will be finding out in when we create the classes and we'll be writing down different functions, member functions. Then the scope resolution operator is important. And to understand means to specify different scopes also it is important. So you will be finding several uses after this scope resolution operator. Okay. So today up to this, is there any confusion till now?
No, ma'am.
Okay. So I'm stopping the presentation and you can also stop the recording. Okay, so let us